The corner cabinet spaces in kitchens tend to be underutilized due to their awkward positioning. Their location makes it difficult to access food items that are stored deep inside the corner. Forgotten items can be left to expire, wasting the user's food and money. For people with limited mobility, maneuvering this hard-to-reach space can lead to physical strain or injury. This risk is especially great for Canada's aging population. As of 2017, 16.9% of the Canadian population was aged 65 or older, and this number is expected to increase to 25% by 2047. Current solutions include using a rotating Lazy Susan or building a wide diagonal cabinet door that intersects the cupboards adjacent to the corner. Diagonal cabinets decrease the size of highly accessible adjacent cabinets, decreasing space utility. Lazy Susans require users to turn heavy shelves in addition to wasting adjacent cabinet space. A general solution must retain the standard base cabinet size of the corner, leaving adjacent cabinet spaces untouched, and does not require users to exert physical strain by reaching deep into the cabinet. It must allow users to identify their food items by viewing the label, similar to a traditional cabinet experience. The Handy Pantry is an automated food storage device to be placed in the vacant corner cabinet space. It occupies the corner of a standardized corner cabinet and involves an autonomous loading and retrieval mechanism which minimizes a user's physical interaction with the inaccessible corner region. It contains a loading and retrieval dock installed on top of the counter. These qualities distinguish it from current solutions of diagonal cabinets or Lazy Susans, which either intrude on adjacent cabinet space or require physical exertion by the user. With the use of mathematical modeling, we were able to make many design decisions for the Handy Pantry. For the rotational mechanism, the required motor torque was calculated by considering the moment of inertia of the platform, the angular acceleration needed to achieve optimal rotational speeds, and the friction of the bearings used. We decided to go with a safety factor of double the required torque to account for misuse and degradation of the system. To determine the best mode for horizontal extension of the arm, we calculated the target acceleration and expected friction between the heaviest food items and the platform surface, as well as between the rack and aluminum fixture. Based on the pinion gear diameter, we calculated the required motor RPM in order to achieve our target speed. For vertical transport, we first determined the required linear speed for an 8-second transport. This allowed us to find acceptable ranges for the motor RPM and lead screw lead. The lead screw torque equation was used to determine the necessary torque for both starting and running the motor with this lead. A safety factor of double the required torque was included in case the RPM needed to be increased, as well as to account for overloading of the device and degradation during use. The Handy Pantry's touchscreen UI allows users to insert and retrieve items. Interacting with the UI takes under 2 minutes for storage or retrieval. Photos of new items are taken using an embedded PyCam, and these photos identify the items in the UI alongside storage date, name, and food category. The memory module simulates the storage locations of all food items and available storage locations and can retrieve this information from its databases in less than 2 seconds. When an item is removed or stored in the pantry, the memory module updates the databases accordingly. The memory module tracks the expiry dates, photos, and associated data of all food items and provides this data to the UI as needed. The vertical transport module is able to move food items from the loading area to the storage shelf or back in under 8 seconds. It positions itself slightly above the shelves for storage events and slightly below the shelves for retrieval events in order to prevent food items from clipping. The mechanism can locate to within 1 millimeter of the targeted shelf while moving at full speed under a maximum load. The horizontal transport mechanism moves food items of the maximum rated load between storage and the vertical transport shaft in under 3 seconds. The claw ring is capable of moving and collecting food items of various sizes and prevents food items from tipping or falling during transport. The shelves can support a weight of over double the maximum load. The rotational assembly can turn at 20 RPM even while under a maximum load and achieves an angular precision of 3.2 degrees. This allows it to turn to any storage location in a maximum of 4 seconds, accounting for acceleration and deceleration. The Handy Pantry, storing without rummaging.